Without further ado, could we welcome Ian? Ian's a friend of the Society. He's done one or two things with us over the past. Ian, of course, is Birmingham University and Earth Heritage Trust and leads on the Erratic Boulders Trail for Birmingham. But tonight, we're going to get a bonus of a little bit more than that, I think. So, without further ado, I'll hand over to Ian, who's going to give us some amazing Erratic Tales.
Well, thank you very much, Graham. Well, I mean, these are easy. They're just a walk in the park. So I'm going to spend a while telling you about how we got on in this project. And as you may know, Julie and John Schroeder from the Black Country Society have been very heavily involved, as well as a number of other members working as volunteers. But Julie and John in particular produced those leaflets with amazing attention to detail. So that's a tremendous output from the project. And you may have heard Julie say, we want another project. We want the people of the Black Country to do another erratic, because there's a whole another hinterland of erratic stones that are just awaiting more study. So I will make some reference to that later in the talk. Now then, there will be some of you who might not have known what an erratic is. Some of you may have said, an erratic, what on earth's that? Well, it's a stone where it shouldn't be. It's a stone that's taken and into a glacier and moved to a different place so that the stone looks out of place. It's on top of a different type of geology. That's an erratic. Now I'm going to play with you a bit by talking about erratics and not erratics. When is erratic, not an erratic? I'll give you a bit of background about the different ice ages that we've had in England, and then have a look at some modern glaciers, just to show you that actually erratics are not that common when you look at modern glaciers. Then I'll dive into the project, that Birmingham Erratics project that's been mentioned, and then talk a little bit about what are the special and unusual things that you need in order to get an erratic boulder, and then move on to thinking about the area to the north and west of here, and how that relates to the Birmingham area in terms of the types of erratics that are present, and the potential for you to think about doing another project there. So this is such a lovely place. I've recently started learning to play the concertina, and the concertina is often associated with Irish music. And I remember going to the pub in Doolin with the family here in County Clare and thinking, what a magical place it is. And when you go outside and look at the geology, then it's amazing too. So you've got this extraordinary limestone landscape, where all the soil has been stripped off because of over-intensive agriculture thousands of years ago. But then, amidst all this amazing limestone and karst scenery, you've got these things like that red boulder there. Completely different composition that have been dropped by ice and just left there. Clearly something very out of place. So I think that's a sort of great idea to show how exotic these erratics are. And note to self, visit Norber, because one of the most famous places to have strange erratics is Norber in Ingleborough in the Pennines, where the limestone, the erratics are actually on little pedestals of limestone, where the limestone has started to dissolve away after the erratic boulder was deposited. So I haven't been there, so I haven't put any pictures up there, but it's a note to go there. And I suggest you do too. It sounds like a really wonderful place to go. And here's another place I have been, which again brings out the allure of these extraordinary stones. So we're on the Isle of Arran now, and you've got the red sandstones there, which are on the northeast coast of Arran, around places that I can't remember their names. Corrie, yes, we're on the Corrie shore here. And then we've got granites. These granites haven't come very far, of course, plenty of granites on Arran. But the contrast with the red sandstone is really quite evocative of a great feature of that shoreline. And then, of course, we've got this sort of thing here, a tremendous array of lovely stones, not erratics. Well, they probably were erratics once, but they've been moved to Birmingham, and they are nothing to do with Birmingham, in terms of the natural heritage. So developers think that people like large stones. Well, people do. Children love to climb on them. Everyone loves to look at it. Everyone loves an erratic. But the problem we found, and one of the justifications for our erratics project in Birmingham, is that the genuine erratics, the ones that actually tell us something about the natural world, are being overwhelmed. They're being swamped by all of these lovely stones that developers have brought in. And that example in Cannon Hill Park just illustrates that. Oh, what about this one? What do you think of this? That looks as though it's... What kind of stone is that? A monolith. Yes, it's a monolith. It's a standing stone. And the question is, when people thousands of years ago wanted to put up a religious monument as a monolith, did they use erratics or did they quarry them out? These are tricky questions. I mean, this is on the Isle of Jura. So that stone is made of a basic igneous rock which forms an intrusion in the local quartzite on the Isle of Jura in Scotland. And there is the outcrop of the intrusion. Here's the standing stone, so it's not very far away. But is it an erratic or not? Well, if you look at it end on, you see, no, it's so thin, there's no way that could have been transported any distance by ice. It must have been, people must have just carried it there. Stonehenge. Now, Brian John said that the blue stones, which are these stones here, just inside the main sarsen stones, that those stones were glacially transported. That's what he said. We know that the sarsen stones are local silica-cemented sandstones from the area of Wiltshire. The sarsens are more exotic. He said, that's because of glacial transport. But a lot of people thought that can't possibly be right. There were no glaciers down as far as Wiltshire. And indeed, people have now found the quarries in southwest Wales where those stones were taken from. And so the archaeological investigations have shown quite clearly the blue stones were quarried there and that they were transported to that Stonehenge site as part of a major engineering project by our ancestors. But sometimes the erratics get mixed up with the archaeology. I mean, this is one, for example, it's called the Wren's Egg at Dumfries and Galloway, where there's an archaeological site and there's an erratic sort of next to it. And everything is kind of getting a bit muddled up. And was the archaeological site there in part because there was already a stone there, which gave it some special or mystical significance? Another case is the Kilmartin Glen in Argyll. It's a wonderful place with lots of monuments, all within an area of a couple of square miles. But there are old stones here which look as though they're erratics there. Now, what kind of relationship do they have to the monumental stones there? And this is perhaps the favourites. One I went to on holiday this year, not knowing it was there. So I spent a day on the Isle of Tiree in western Scotland. And one of the tourist attractions on the Isle of Tiree is this stone, and it's called the Ringing Stone. As you can see, it's swamped by tourists because this is one of the main tourist attractions in Tiree, but it is 2 miles from the nearest road. So, not surprisingly, it's not much visited. And I talked to a geologist last week who was enthusiastically telling me all about his holiday in Tiree this year, and he hadn't been to see it. So, some people are not, need to be made of sterner stuff, don't they, to do that? Well, it is extraordinary because there are actually extremely few erratics on the Isle of Tiree. I did find another one that was several miles away. So it is very unusual, but it's also got those strange marks on it. They're cut marks. The archaeologists are pretty sure that they were made by people about 4,500 years ago. But why they were made, there are all sorts, as you imagine, with archaeologists, all sorts of weird and wonderful theories, most of them involving fertility. The rock itself is made of a basic igneous rock. It's from the Isle of Rum, so it's transported across what is now sea, quite different from the local nice bedrock. And it has a strange property. If you tap it with a smaller stone, you get a ringing sound, so that's called the ringing stone. So you can see that prehistoric people would be really intrigued by something like that, something out of place, out there on the shoreline. It's not too big to move. I mean, people move blue stones, don't they? But I don't think they've moved it. So that's certainly, at the moment, that's my favourite erratic stone, apart from all the ones in Birmingham, of course. Now then, let's give you a bit of background about the ice ages in our area, in our part of the world, in England. And we see, as we go, we follow the arrow of time from right to left, and we go from several million years ago, when there was no big ice sheets in the northern hemisphere, through to the Quaternary period, when in the last 2.6 million years there have been repeated episodes of cold and warm, oscillating with great rapidity, as you can see on this diagram. And we're going from full glacial periods, when there was a big ice sheet over whole of Canada, basically, and interglacials, where the ice is on Greenland and sea ice in the Arctic Ocean. So those are the sort of alternations we're looking at. Of course, there was ice in Antarctica all the way through. But we have those glacials and interglacials. And in the glacials, of course, we get glaciation in Europe as well. Now, if we look at England and the continent of northwest Europe here, back in the beginning of the Quaternary, so we're now looking at about 2 million years ago, sometime around here. At that point, the English Channel had not formed, it hadn't been breached, and there were lots and lots of rivers flowing, many of them in different courses from those that we see today, particularly in England. So there are lots of gravels, for example, in places like Warwickshire, which reflect rivers that no longer exist. So that was before there was ice. We actually don't really know when the first ice age on land in England was. It's quite difficult to reconstruct because of erosion since then, but probably between 1 and 2 million years ago. But the biggest one is believed to be the Anglian Ice Age, and the Anglian Ice Age is just a little bit less than 500,000 years ago, and it's the most intense of these cold cycles, as shown on this diagram. I mean, this diagram is constructed by measuring the composition of small fossils in the ocean, which give us an indication of how much ice there is in total in the whole world, because the composition of seawater changes as the amount of ice builds up. So we know that this was the most extreme glaciation sort of globally, and certainly in terms of northwest Europe, it was a very extensive glaciation. We know it covered the whole of East Anglia, approached London, and we presume came through Birmingham as well, and which may explain how many of the erratic stones first arrived in Birmingham. But there aren't any. Yeah, I mean there is some evidence to indicate that ice did indeed reach Birmingham, which I'll show in a moment. but not directly from the erratic stones. At this stage, then, there had been floodwater going through the Straits of Dover, so that English Channel does exist at that point, and we see that there were major rivers flowing through what is now the Channel. And then if we go through to the period about 150 to 200,000 years ago, it's a bit closer to the present day. So if we go back to this diagram again, somewhere around here, there may have been 2 or 3 glacial episodes within the last few 100,000 years, but there's particularly good evidence been published recently for one around 150 to 200,000 years ago, which may even have been more extensive in the West Midlands than the earlier glaciation. And this is called the Morton Glacial, after Morton in Marsh. And it's during a long period in the Quaternary, which is known as the Wolstonian. But in the Wolstonian, there could have been several different ice advantages, but this is the one that's perhaps best documented now. Now, in terms of Birmingham then, that glaciation almost certainly would have had a role in bringing in erratic boulders or moving erratic boulders that were already there. But it's a little bit difficult to get a handle on exactly what happened then as compared with what happened in the earlier Ice Age. And then if we go to the last Ice Age, and this one is particularly relevant to Staffordshire and the Black Country, the last Ice Age, the ice didn't reach Birmingham, it just reached the edge of the West Midlands, and there was a great piles of glacial debris in Wolverhampton area, for example, and the river through the Channel was pretty enormous by this stage. We'll come back and look at what that, the reconstruction of that in the West Midlands area later in the talk. So that's the overall picture, that there are lots of different ice ages. They had different extents, and trying to disentangle the effects that they have can be quite tricky. Let's go to modern glaciers now. And this is a glacier I worked on for several years in Switzerland. It's called the Glacier de Saint-Florent. It's built on a plateau of limestone, which is over here. This was what it was like in 1990. Sadly, now, 30 years later, it's retreated enormously. And in 1990, it had already retreated about a mile from where it was in the 19th century. So, these ridges that we can see here are push moraines caused by the glacier kind of going forward each spring, melting back, going forward again, melting back, and all the time you see it's the snout of it, the front of it is retreating. So these in the 1920s it was here, and then it's gradually got further and further back. So we look around there. I haven't got a scale on the picture because the scale varies, but there are a few larger stones, but there's not that many actually. Most of the debris is reduced to the size of pebbles or cobbles. The biggest pieces of rock actually are those that have fallen from the cliff. And what's happened here is that they've fallen onto a piece of the glacier which has moved forwards, and then it's stagnated because we're at the front of the ice now. And what we've got here, that mound, is an ice-cored moraine. It's a block of ice with boulders on the top, which is gradually melting away. And by the time it's finished melting, it'll be a pit filled with boulders. So all very odd, the idea that the topography inverts itself over time, but that's typical of the weird way in which glaciers behave. So something that's fallen off a cliff would be very sharp and angular in outline. Most erratic boulders are not like that. So we've got a bit of a strange thing there. The biggest pieces we can see actually don't look like typical erratics in that context. But of course, we're only just looking at the surface there and looking in one place. Now, something else I wanted to show you is the way that a glacier would erode pieces of rock. How would it grab hold of them and entrain them in the glacier? Well, a very good way of doing this is to, well, I don't know if any of you have tried putting your hand on some aluminium in a freezer, you know, at minus 18 degrees. You'll find your hand will stick to it. And so it's a very effective way of adhering to it. So if we have a glacier moving over an obstacle like that, this is the place where ice is forming. This is the place where ice is melting because of the high pressure on that slope there as the ice is moving forwards. And here we've got a low pressure zone, and that causes the water to freeze. So melting and freezing occurring within a short distance of each other. And where the freezing occurs, you've got the possibility of freezing on, and then the glacier can pull and tug at that rock, and any small weaknesses in the rock could be taken advantage of, and you then can dislodge a block. This actually is a precipitate of calcium carbonate that is also forming by freezing. So it's actually telling you where the freezing occurred in this particular case. And because I worked on this glacier, this is the same glacier as you've seen just now, because it was based on limestone, so there's plenty of lime around. So there's a diagram that shows you how the blocks can be taken off by the ice, and what they're doing is they're freezing on, and then cracks that are present in the rock can be exploited and opened up, so we can take out blocks of material. And then once you've got a block inside a glacier, you can start to grind it and wear away at it. And quite a lot of the debris, rock debris, inside a glacier is reduced to a fine paste. It's what is called rock flour. It's not very edible. In fact, it's extremely unedible. I wouldn't recommend it. Now, most of this rock flour is really very, very fine. It's kind of silt-sized. There is a material that's a few millimeters across, but the vast majority of material that is created by glacier erosion and transport is really fine, this rock flour. And so when we look at a glacial deposit, if one is exposed somewhere, they're often what used to be called boulder clays. You might see boulders or pebbles or cobbles, but they're in this very fine matrix that it represents crushed and ground particles. And this is the sort of place where the crushing and grinding is going on. So here we've got 4 professors of glaciology there. Well, they weren't all professors of glaciology at the time, but they subsequently became so as reward for going around in shorts by glaciers. So here we've got that same glacier I was showing earlier on, and we're now at the margin of it, and in the basal part of the ice there will be lots and lots of rock fragments that have been taken off from the substrate and transported along. And this is an unusual place where the light is actually shining through a little piece of the glacier, so you can actually see the different layers of debris in the ice. That's very unusual to be able to do that. And so you can see that there are certain layers that are very rich in the debris and layers that are poor in the debris, and it's all suspended in the ice. And then that material melts and forms this quagmire, this muddy ground here at the edge of the ice. And here the ice is adjacent to a lump in the bedrock, and there's like a little cave forming where the ice is going around the side of that. So all sorts of really fascinating things occurring in that modern environment, and an environment that's very, very active in terms of doing things to rocks, breaking them up and making them into smaller pieces. Now, where you do see pebbles and cobbles then, they change their shape in this basal zone of the glacier. So what we were talking about just then is the part of the glacier that's near the bottom. It has more debris in it, and there's a lot of crushing and grinding going on there. On the surface of the glacier, these are pieces of rock that have been shattered by frost. Some of them may have fallen onto the surface of the glacier. In fact, probably most of them have in that case. And they're very, very angular. So frost-shattered blocks are very, very angular. Whereas material that has been transported underneath the ice is changed quite dramatically in its shape. So the typical characteristics are that flat faces are broken, a bit like chopping the top off an egg by fracturing. And then the smaller particles come along and they grind away at the surface. So the surface becomes very smooth. Slightly bigger particles, harder particles, scratch themselves across the surface. So we get these glacial striations as well as the rounding of those faceted surfaces. So very, very characteristic features of subglacial transport. One other fun thing that's shown on this diagram is that at the margin of the glacier here, you often have a situation where a lot of freezing occurs at that margin, which causes the layers of ice to ride up over one another to form these thrusts, which brings debris from the floor of the underneath the glacier up to the surface of the glacier. So here we are in Canada, and these mounds of debris here are the surface expression of thrust fault bringing up debris from underneath up onto the surface. So again, we look at it and it's mostly pebbles and cobbles, not very many boulders present there because it's so, the original pieces that are eroded may not have been huge, and then ones that are bigger tend to get broken down quite easily to these smaller fragments. So this is all. So these slides are all to tell you that erratics are not that common in modern glaciers. So when we do see erratics, they're special. So we've got to treasure them. And here we are in Birmingham, and here's a rarity. You see, there's an erratic that's exposed. This is in the Hockley Heath area. Julie knows all of these photographs, so that was exposed in this trenching work. It's in one of these boulder clay deposits. You can see there's a lot of pebbly material there, a clay matrix, and a single boulder. So this is what we think it's like, that the boulders are actually very few and far between, such that it isn't very often that new ones get discovered. So Roland Kedge here, who was the original inspiration for the Birmingham Erratic Boulders project, said that a boulder like this one, which was dug up in Bromsgrove 3 years ago, was the first new one he'd seen that had been freshly dug up for decades. So something a bit unusual. So they're very thinly dispersed through the blanket of till, of boulder clay. Okay, well, let's have a look then at this project that we ran, which finished back in September. Though the admin to try and finish it is still going on. And indeed, we've still got some interpretation boards to go up, and which the company that's made them isn't responding to our emails at the moment. So we want them put up. And when do we want them put up? Now, that's right. Right, so an inspiration for this project was that the Victorians showed just how exciting erratic boulders could be. And they traced where they'd come from, and everybody in Birmingham would have known at the time about these boulders, and I'm sure people in the Black Country too, because a lot of boulders have been sort of marked and celebrated in Wolverhampton, for example. So the funny thing is that they went out of fashion, and you can see why it started, because it was really the First World War that seemed to draw a veil over the excitement about the boulders. You know, that very, very serious time meant that it took a lot of the wind out of the sails of this, and people just moved on to other things following the excitement of the Victorian and Edwardian era and discovering these things. So we wanted to rekindle that excitement, which I think we succeeded in doing. And so this project involved a partnership of 4 organisations. Of course, the Black Country GeolSoc was very much involved in it. along with the Birmingham Open Spaces Forum, the Lapworth Museum, and the Herefordshire and Worcestershire Earth Heritage Trust. And obviously we needed a lot of help and cooperation from Birmingham City Council, who run the parks departments. And for example, Mike Hinton here was very helpful in advising how we could improve the context of this boulder in Cannon Hill Park. It's now got a hard stand, a porous membrane around it, so it's not got the moat around it as was the case a few years ago. And here's Ken Lewis, who's here this evening, involved in some of the public engagement that we're involved in the project. I think many of you came to see the temporary exhibition at the Lapworth Museum, and this is just a plug to say it's still available, and there was a hint that it might come to Dudley at some point and be in this building, and it's there waiting. So if that opportunity presents itself, then I think that will be great to bring it over here as well. So that's an open door for that. At the start of the project, then we knew about 100 stones, and the vast majority of those Roland and Julie had discovered, and by the end of the project we'd increased that by 50%, and we'd created these 8 trails, which some of which were very similar to what we had originally planned, and some of which were rather different. So that's been a great output of the project. All the trail leaflets are over there, and that's a fantastic thing. We've got a great website, and those social media are still running for the next few months as well. And Julie has produced a wonderful documentation of what was going on in the 19th century and into the early 20th century, centred around the West Midlands. So Henry Crosskey, Unitarian minister in Birmingham, was a nationally important figure as secretary to the Erratic Blocks Committee, which took in all the observations of where people had found these stones in different places, and maps were made tracing them back to their sources. He left also a great collection of samples which are in the Lapworth Museum, including a number from this area. So Julie's written an extended essay all about this, which is really interesting, that's on our website. You can see the address there. In doing the project, then we found all sorts of disconcerting things about how people just forget things. It doesn't take very long for the news cycle to move on. I mean, these days it's kind of week by week, but you'd think in local communities you might remember key events, for 20, 30, 40 years, but it seems not necessarily. This is Romsley Hill. Now, Romsley Hill used to have a lovely erratic boulder that's come from North Wales, from Erratic in North Wales. There it is, recorded in 1902. No sign of it now. Who's had it? What have they done with it? They haven't eaten it. What have they done? They buried it, broken up. They're very tough rocks. You'd think that they would survive, but anyway, that's gone. And instead of that, in that same place now, we have these. We have a concrete plinth on which there are 2 big boulders of basalt, which are from Rowley Regis, not very far away. And Roland mentioned this to me. He said, these have come from Rowley Regis. Glacial boulders from Rowley Regis have been recorded in Romsley Hill and Frankley Hill nearby. He's quite right, they have been recorded, but I'm pretty sure that those are not glacial erratics. Because I remember going to Rowley Regis Quarry in the 1980s with students. It was still open then, and there is a rumour going round in Romsley that when Charles and Diana got married, they thought it would be nice to have a monument, and they made this plinth. So if that's true, that's in 40 years, none of the parish councillors can can verify this. Nobody seems to remember. Nobody knows. It's all gone. We can't find any local records about it. So if you don't write these things down, they do get forgotten. Because the art of telling stories in the evening is lost, isn't it? The oral history isn't there in the way that it was. Thousands of years ago. Generations after generations would keep those stories of the ancestors going. It's not happening now. So we've got to write it down. And this is someone who looks like Roland, but in fact is his father, and that's his son. And this was taken a few years ago. And this is a park which, now I always get confused about the name here. It's sometimes called Grey Fox Park. It's near a road called Garland Way. But actually on the map, the park doesn't have a name. It's quite bizarre. And it's in Northfield anyway. And look at that lovely, lovely erratic boulder there. You think everyone would be very proud of that. But 40 years on, it had completely disappeared in this huge thicket. So someone wasn't treasuring it. And in fact, it was the Bourneville Village Trust who would just let nature grow up all around it. But after a bit of persuasion, they did allow some clearance around it, although they've still put a fence in front of it unnecessarily. And so it is at least visible again now. But stones do get, if not destroyed, they can get hidden. And we've actually moved some stones in Woodgate Valley Country Park from places where they are hidden to places where the public can see them. Not long distances, but short distances to do that. This slide just illustrates a difference in shape. So this one, you can see, has got very sharp corners. So this looks as though it hasn't been transported underneath a glacier, or at least not for very long. But it may have been carried along on the top of a glacier or inside a glacier. And that's perfectly possible for blocks to be carried for long distances in that way. This one, on the other hand, is quite nicely rounded, and it's got some strange marks on, which could be glacial striations. This one's outside Bourneville Station. So there is work that could be done, and we haven't really done this, to look closely at the shape of all these different boulders and infer something about the glacial transport. Now then, let's go back to this thing about, there aren't very many erratic boulders in modern glacier environments. So what's the special things you need to be able to form one? So you need to be hard, not only as hard as nails, but even harder than nails. There shouldn't be cracks in the rock. Any joints that are cracked, those are cracks. Those should be widely spaced. And you shouldn't be able to dissolve it very easily. It should be chemically resistant. In other words, it shouldn't be susceptible to weathering by rainwater or soil water. This is the place in North Wales where most of the Birmingham boulders have come from, Erratic Vawr in North Wales. And we've got some really quite big blocks. These have presumably been transported in the last ice age, very close to that Erratic Vawr mountain. But you see, it's a pretty tough, hard rock. It's got some cracks in it, but not very many. And so you can imagine yourself quarrying off really big blocks of material from these widely spaced joints. And the rocks themselves are really very tough. And this is some examples of some of those volcanic rocks from the Erratic Vawr mountain. You can see that they've got layers in them. And the layers are marked by sort of rounded pieces, which are pieces of volcanic rock, and these black, flattened-looking pieces. And those are pieces of pumice, that is volcanic glass full of holes, that gets squashed flat when you have an intense hot eruption, a pyroclastic flow eruption. So that's what's happened in those cases. And what happens when this really hot eruption happens is that the whole thing is immensely hot. It's a bit like something you might cook in an oven, and and which changes its character in the oven, and it might squash down and so on, whether you mean to or not. Maybe it's your souffle that does that. So one of the things that happens is that silica precipitates from solution, and it fills up the cracks and holes inside the volcanic ash deposits and makes them super hard. So we can see this in a microscope view. So pumice then starts off life as basically holes with a bit of volcanic glass around them. I don't know if any. Does anyone use pumice in the bath now? Some people do. They make artificial replacements for it now, but pumice, and you can, and some Mediterranean beaches, you can pick it up. I understand. It floats on water. It's so light. And pumice is made of basically tubular holes where gases have escaped from a lava when it's come out into the air. And what we're looking at here is the microscope view. So this is a cross-section through a tube, and it's quite small. It's less than 1 millimetre across. But in the crossed polar view here, you can see the grey to yellowish colours of quartz. So quartz is that silica, SiO2, is precipitated inside those tubes. So everything is toughened up by that chemical change soon after deposition. So these rocks are really they're manufactured and ideal for becoming erratics. So I'm not quite sure I put this slide in at this point. Perhaps I wanted to show Roland again. Here he is. Here we are launching Trail 1. And of course, he was the one that worked out where a lot of the boulders are today. Now actually we know very well where they were in the 19th century because they were plotted on maps. But at least 90% or 95% of those that were plotted on maps in the late 19th century are no longer there. So Roland did this very valuable job of sniffing out where boulders actually still are. And this is a boulder that is, you could say, is close to my heart because of my failure to take any notice of it during all the decades that I worked at Birmingham University. So this is again, it's a matter of how people just forget things. So I arrived in Birmingham as a young geology lecturer in 1980, a long time ago, 43 years ago. How old is your dad, by the way? Is he 43 years? Is your dad 43 or is he older?
No, he's 41, I think.
41. So, yeah.
Sorry, I get confused.
So, well, that's a long time. Anyway, a long time ago, when your dad was a baby, I started work here. And there was this lovely stone that was kind of hanging around there, and I didn't take any notice of it at all. And there were older colleagues who'd been around the university for a long, long time, and they took me on field trips to see evidence of the Ice Age. And we went up to Cheshire, went to Shropshire, we went down to Worcestershire, but never once did they say anything about that stone. That stone was dug up in 1909, 114 years ago, but nobody ever wrote anything down about it at all, except there is a newspaper report that we discovered, which is completely garbled, a bit of hack journalism, that talks about the boulders from Erratic in North Wales, but this one clearly isn't from Erratic from North Wales. It's a completely different sort of rock. But it is the only genuine erratic on the university campus, and there are hundreds of boulders that developers have brought in to litter the university campus with. So we've had to pay a bit of a rearguard action to try and get this boulder celebrated. And even now, we've got a problem because the university want the contractors who install the interpretation board to have the appropriate safety protocol. And the contractors say, oh, we don't have that, we don't know what to do. So even now, we haven't got the board up to tell people what it is, but we're close. We are inching closer towards having that board up. In the meantime, there's a web page that tells the story about what we found out about it. And it really is quite bizarre that we thought it was completely made of basalt from Rowley Regis. And lots of geologists have been there, and this is Ian Stimpson from Kiel here, who knows a thing or two. And we all went and we said, oh, this is a very fine-grained dark rock, it's basalt. And indeed, I'd taken a thin section and found it was basalt in 2018. But then we did some chemical measurements, and we said, this isn't basalt. What's going on? And in fact, 90% of it is not basalt. It's actually coal measures. And there is a report in the Geological Survey memoir to say that there is a place in the old quarry in Rowley Regis where coal measure sediments are baked black at the contact with the intrusion. And that baking makes them hard and therefore makes it possible to form such a big erratic as this. If they hadn't been baked, they wouldn't be an erratic. However, they're not as hard as the basalt, and so they can still take scratches. You see those striations there? Now these striations are really magical because you go to that stone, you might go there 20 times and you won't see those striations. It's only when there's a full, no. It's only when the sunlight is in the right direction that you see the scratches and the striations, and they're magical when you see them there. So there's a lovely story about that then on the website. And we were cleaning boulders. My brother runs one of the two biggest companies in the country which clean stone for historic buildings, or make machines that clean stone for historic buildings. So he kindly came up with one of their machines. Now everybody says this is steam cleaning, and it isn't. It's pressurized water at 100 degrees C. Apparently it's not steam. Mustn't say steam. But look at the effect that it has. Look at that. So there's a boulder that's been lying around in a field for forever, and look how it cleans up. So that's in Woodgate Valley Country Park. That one's got paint on it. That was behind a fence and covered in paint, and after a lot of careful work, that's been cleaned. But of course, a lot of stones. We could only do that for a few stones, but actually, a bit of elbow grease and you can achieve a lot. And so volunteers from the society have done a fantastic job. And you can see Malcolm there is resting, a well-deserved rest after cleaning that boulder. And over in Broad Hidley Wood, great work by this team here, helped by Alan Richardson's pressure washer. And this is an extraordinary boulder. It's made of quartz, vein quartz, from the North Wales area. And it's as tall as I am, so it's quite an extraordinary thing. And we did suggest moving it to the visitor centre, and the local people in Broad Hidley said, do not do that. So we obeyed, and we haven't done that. And so it's a kind of charming secret in the Broad Hidley woods. And it's on Trail 8. But now some people thought that graffiti was okay because it said "you rock," and it was in an environment where there's lots of other graffiti. It was next to a bridge which was covered in graffiti. So some people said, well, it's not. It could be worse. But nevertheless, we went and my brother came back up and we cleaned it off. But it took quite a lot of work, actually. It took about 40 minutes to do that. It was a particularly well graffitied. And it's now got an anti-graffiti coating on it to try and make it easier in the future to remove graffiti. Right, we're now going to sort of think about this area as well as Birmingham. So let's just go back and say what the Birmingham story was. So the Birmingham story was that this place, this is the mountain of Erratic Tales, which has got this enormous cliff, and it's this great hollow filled with water. So this is all glacially eroded, and this is very clearly glacial scenery we're seeing here. And when someone produced a computer model to reconstruct what the Welsh ice cap was like during the last ice age, and Erratic Tales is just here. It's right in the middle of the ice. So it's where the ice would have been thicker, over 1 kilometre in thickness, just there. So that's the site. And then boulders and all kinds of debris were eroded from that and transported away to the east. Now, in the last ice age, that ice coming from Wales got so far, and then it was stopped. It was occluded, it was stopped because there was a faster moving stream of ice that had come in from the Irish Sea and was coming down this way and bringing stuff from the north down there. So that was the situation in the last ice age, but not in the in earlier ice ages, as we'll see. So it's these sort of incredible volcanic eruptions that give rise to the deposits that we see in Arenig in the Ordovician geological period. That was what made the volcanic those sort of volcanic eruptions that made the rocks that became the erratics from that area. And here we see these squashed pieces of pumice from there, and we see an example, an unusually large example of one of those erratics. This one's about 3 meters across in the Bromsgrove district. So that's a sort of Birmingham story, is stuff coming from that place. And we see here a map, and this is a map from 1879. So it was the first map that was produced showing, bringing together observations. So up until that point, the collection of data had looked extremely dull. So what had happened was that the British Association for the Advancement of Science had set up a working group, the Erratic Blocks Group, Secretary H.W. Crosskey, and they solemnly wrote their reports each year, and they said, a boulder has been found made of Arenig ash. It's been found in this field here, and it's this big. Then they said, another boulder has been found. This is also a Arenig boulder. It's been found just here, and it's this big. And these lists and lists, it's classic what Rutherford called stamp collecting, but which, of course, is the very meat and drink when you need to get primary empirical data to build up a story. And in the 19th century, you could get this information. You can't get this information in the same way now because of urbanization and all the destruction that's gone on. Well, also mechanization of agriculture, which has led to a lot of destruction of natural features on the surface. So in those days then, back in the 19th century, this is what they found. They found pieces that have come from Arenig. Here, they found them here to the east. And so they were able to draw these lines showing how ice must have fanned out from Arenig, fanned out towards the north, fanned out a little bit towards the south, but certainly going eastwards. And then they didn't find any more until they come to Birmingham, down here, and there they were again. They were down here. So this was the weird thing then. So they had them here, they had them there, and there was none of them in the middle at all. Instead, what they found in the middle were pieces of granite. And these granites, they were able to trace back right up there to the Lake District and Scotland. So that's indicating then that there are two different streams of ice, one flowing from north to south, bringing the granites, and the other one flowing from the to the east, from the Arenig region. So one thing this is a bit of slightly more subtle point, is that the boulders that we find in Birmingham were from an old ice age, but the same rock type that's over here is actually from the last ice age, because all of the ones from the older ice age in all this area have been obliterated by later action. It's only in Birmingham where there hasn't been a recent ice age that we still see these things present. So so people were in the 19th century. Then people were really puzzling about what those things actually meant. Could it be that you could have two streams of ice crossing one another and producing two different trails at the same time? And of course, they didn't have the benefit of having aerial photographs of glaciers to know about that. But now, what we can say now is that if you get this aerial view of two glaciers meeting, is that where they meet is a bit like squeezing toothpaste out. Where they meet, they kind of one squeezes the other, and the more powerful one will squeeze out the other one. So this one's getting really squashed and squeezed here, and this one's, the more powerful one is carrying on in a stately manner. So that's what happens at the same time if you get two different streams of ice. But on the other hand, when you look at ancient barren lands, like a lot of interior Canada, you can actually find lines crossing one another, basically gouges in the bedrock in Canada. And that's 100 kilometres across, so that's an enormous scale. So what this represents are different ice ages where the ice was moving in different directions. So it's not unusual to find ice moving in different directions in different ice ages. It all depends on where the biggest build-up of ice is, pushing the ice forward. So to have ice from Wales coming down to Birmingham and beating ice that comes from somewhere from the north, you basically need a lot of snow in Wales, and to build up a big ice sheet in Wales to make that Welsh ice move quickly and dominate the picture. So if we home in a little bit on the Birmingham area, this is a slightly later map from 1890, which gives a lot more detail about this area. And it spells Bridgnorth incorrectly, as we would say now, but then that's probably the antique spelling of Bridgnorth. Fred Martin in 1890 said, "There can be no question of intercrossing. The boulders we find are the remains of two distinct periods of action." Because some of his colleagues were saying, we think that these two things could have formed at once. And he said no. And his view proved to be correct. So in the Birmingham area, for example, we find this kind of big ring of boulders here. So what does that represent? We simply don't know. It could be some kind of end moraine, where the furthest extent of ice. But which ice? Was it the original Anglian ice, or was it some later ice that came hundreds of thousands of years later? We don't have any way of doing that. So this is we just earlier on in 1879 map, we just looked at this area, but in fact that 1879 map covered all the area all the way up to Scotland. And from that, it's possible to see that the Criffel granite in Scotland, which is a white granite, was the source of many of the boulders. And the other one is the Eskdale granite around the west of the Lake District, which is producing the pink boulders. So they did come a long way. You see, there was a couple of 100 kilometres that those granites have come. What I've done here is to painstakingly add the dots from those 19th century maps onto a modern map, so we can see where they should be. So there's a registration error of 100 or 200 metres or so in there, but it gives you some ideas. You can see Wolverhampton here has got loads and loads of boulders, and that was the end moraine, that was the ice limit in the last ice age. And so we can see that on this reconstruction here. There's also an audio track by Joe on the website if you're interested in that, which everyone should be. So the first ice age then, there we are, comes from a Rennig-Vower, whereas the Eskdale and Criffel are further north. There we are, that's the first ice age. And in that first ice age, the ice from the north is not as fast flowing, and so doesn't make it to Birmingham. Instead, the Welsh ice reaches Birmingham and leaves the erratics behind. Whereas in the last ice age, the ice from the north is quicker off the mark, and it cuts off the ice from Wales. And so we get all these boulders around here, and this is now in Wolverhampton. So we've got a different story. It's amazing how there can be such a different story in two places that are so close together. Now, the British Geological Survey, in their memoir from the year 2000, wrote a lot about the Ice Age in glacial deposits, and they wrote one sentence about the erratics. Whereas, of course, when doing the erratics project, we're saying, well, the erratics are really the important thing because that's what the public can see. They can't see any of this other stuff of these deposits because they're all underground, and they may, they used to be exposed in clay pits and things like that, but they're all filled in now. you can't see anything anymore. You might see sometimes in a trench that workmen are digging, you might see something, but it's actually really difficult to get that picture. So what the British Geological Survey were able to do is to draw a cross-section. This is a very exaggerated section across from west to southwest to northeast in Birmingham. And a key, really important thing that was found in Quinton was that they found the record of a warm period between two ice ages. And that warm period is the one after the Anglian Ice Age. And in that region, you see a glacial deposit, a till, a boulder clay, underneath that stuff, and another one on top. So that's implying that indeed there were two ice ages affecting Birmingham. That's the clearest evidence we have that there were two ice ages affecting Birmingham. But it looks as though they were both significant. But when you come over here and we look again at this blue stuff, which is the boulder clay, it's very difficult to work out which layer that corresponds to, because everything changes so dramatically. So it's very complicated, and it's really very difficult to date these deposits. Seb Gibson has attempted to do that, and with the cooperation of Julian Rowland, who led him to some of their best boulders, he had a go at dating them using a technique called cosmogenic isotopes. So these are cosmic rays from outer space that come in, and they're coming in all the time. They attack us when we're outdoors. We don't mind because they're not that dangerous. But their effect is to make new radioactive isotopes close to the ground surface, and their effects die away within a short distance below the ground surface. So if you have a boulder, if you have a cliff of rock and you take a piece out of it, and so you expose it to the atmosphere, from that moment on, cosmic rays will attack it and build up secondary radioactive isotopes inside the rock. And depending on how much you find, you can get an estimate of how long it's been exposed to the air. And so that was the technique that Seb tried, but he ended up with getting some very different ages between 49 and 200,000 years. So none of them are anywhere near as long as 450,000 years, which is the Anglian Ice Age. But on the other hand, what we don't know is whether these boulders stayed still. I mean, they could have been moved and then flipped over in a later ice advance. So the interpretation is ambiguous, unfortunately. But this is a technique that's been used very widely and very successfully in Antarctica, for example, looking at the last ice age. So let's just have a look at then at these different ice ages on a map scale. So here we are we've got Birmingham here, we've got Worcestershire here, and then the ice limit of the Anglian Ice Age, that 450,000 years ago, that's probably somewhere down around Tewkesbury in Worcestershire. And this is a glacier from Svalbard, which is meant to look a bit like Worcestershire, with the Malvern Hills on this side and the Cotswolds on the other side. I had to make it a mirror image to make that work, but anyway, that's that. And then we've got Till, got glacial deposits up in Bromsgrove area and so on. So let's look at the ice ages then. So first ice age, let's say Anglian ice, maybe that went down to there, and then there were streams draining down to Tewkesbury area. And then the second ice age, now here I put it just drawing there. Now Seb Gibson would like that ice to be more extensive than the first one. We don't actually know the right answer, but one or other of them was extensive anyway. That's the second ice age. And then the last ice age just comes as far as there, comes as far as Wolverhampton. Now then, so the last ice age then is bringing all these granites down. This is what the granites look like. So I had a chance to visit the Eskdale area in the Lake District in a field trip a couple of years ago. And what happens in that area is that you get a lot of granites that have come from Scotland, from the Criffel area in Scotland, and the ice actually skirted round the coast of the Lake District and brought lots of these granites there. So you can see they're very pale coloured granite, very distinctively pale. Whereas this is the Eskdale granite here in local buildings in Eskdale, so that's a pink granite. So when you come down to Wolverhampton then, you can tell the difference between those two granites just simply by their colour. Now some of you here, I don't know if any of you here tonight are in this picture. Is that Ken? I don't know. Could that be? I don't know. Anyway, there you are. And here, and these lovely labels have been drawn. A Criffel granite, a microgranite from a Scottish granite. This one's from Eskdale. This is a tuff, a volcanic ash from the Western Lake Districts. So those labels are as good as any I've seen anywhere in the Midlands, actually. But of course, that's just one place where those labels had been put up. But there's a lot of material in collections, and Julie's drawn attention to the Crosskey collection at the Lapworth Museum of Geology at University of Birmingham. There's lots and lots of material there, and some intriguing ones. This is a piece of coral limestone, presumably from Carboniferous limestone. So that's, of course, much smaller than erratic. It's only about this big. But the point I want to make here is that smaller fragments will be much more diverse in terms of their rock types, and so potentially provide a more rich geological story than if you only look at erratics. Because if we think about, a project that could be done in this part of the world, and the north and west of here, you might say, oh, it's just going to be pink granite and white granite. Yawn. I mean, because that's what the Victorians plotted on their maps. But actually, if you start looking around, and particularly looking at some of the smaller fragments, there will be a lot of interesting things there. And as an example of that, this is samples that Roland Kedge collected in Birmingham from a little sunken lane called Bell Holloway in Northfield. And he's got his own saw, and he smooths the surface. And so these are some of the examples, and they're much more diverse than the predominance of Arenig rocks that we see in the boulders. There's lots of there's ironstone and other rocks from the coal measures. They're very quartz-rich rocks, and I can't remember what all these things are, but some sandstones as well. But they're much more diverse, and so potentially a lot more interesting. And so preparing samples in this way, I mean, it's a lot simpler than making thin sections of rock, but I'm sure that some of you have got the ability to saw pieces in half. That could give a rich source of information for any kind of project on that. And you could obviously collect material if there was a trench through a deposit of boulder clay somewhere. And so that's where we are now. This is a triumphant bit of, lovely bit of Dudley. I was so excited to find a place in Dudley that Graham didn't know. And it's possibly the biggest erratic boulder of the lot, just sitting there at the edge of a triple SI in the south of Dudley Borough, and waiting to be exhumed a little bit more, I think, to show it off to best purpose. But that's also on Trail 8, so well worth a visit. So I commend the erratics to you, and I hope that you enjoy them in the future. Thank you very much.
Well, thank you, and that was absolutely tremendous. A wonderful introduction to the whole aspect of how these things get here, where they're from, and what we can do next. Could I ask you all to thank Ian in the usual way?